Welcome everybody to the CO2 GeoNet autumn webinar. We're very pleased you were able to join us today, and it's great to see that everybody's been able to connect online. So that's very, very good news, because even though we've had 18 months of working from home and remote working, it's still not always guaranteed that the technology wants to play nicely. So we've got a very packed program for you today, and I hope you will really enjoy the presentations. I've been looking forward to this event for some time. I see that we still have a few people joining, so I'm just going to open up the first presentation and start to get things ready, and then we'll kick off as soon as I see the list has stopped expanding. So Julia, have we got many more coming in? It looks like we have a good attendance already. Okay, this looks very promising, so I guess we will start. Okay, so thank you everybody for joining us. I would like to introduce our first speaker. So I've been very much looking forward to this presentation from Maria Velkova. And I would invite you to, Maria, I'd like to invite you to start if you are ready to do so. I'm just going to attempt to share. Let's see if Zoom wants to play nicely today. Okay, can you see the slides?
Yes, thank you, Ceri. Yes, I can see the slides. Hopefully everybody else can. Thank you very much for this invitation. I'm really pleased to be able to talk to you again. Because we at the European Commission are working very hard actually to advance the Green Deal agenda, and from what I really would like to focus with my presentation on the progress and what have we done in the last months, because actually I did talk to you, and maybe some of you still remember what I said back in the beginning of this year. So really the focus is not to give you a very comprehensive overview of everything that we do in relation to CCS or climate action, but really just to focus more on the progress and what are the new elements. So if you go to the next slide, please. The European Green Deal. In fact, I don't know, actually, I would be curious to know how much you hear about the European Green Deal back in your countries and when you're working, because I know most of you are really working on the hardcore research of geological storage, and perhaps this European Green Deal is something not just like not so clear what that is. Why is that there? Because on the other hand, we at the European Union institutions hear about the European Green Deal all the time. I mean, it has really changed the agenda in every single policy area in the last 3-4 years. But I will focus, because European Green Deal is very encompassing every possible initiative, as I said. I will focus only on like what is in there for climate action. And in fact, climate action together with preserving the environment are at the heart of the European Green Deal. They are actually the reason that this European Green Deal exists. Because the European Green Deal is a plan to transform the EU into a modern, resource-efficient and competitive economy. The highlight is our objective for 2050, that we want to be climate neutral continent in 2050. But that is too far. We need to do this step by step, and we need to do this in a realistic way, and we need to think about economic growth, which is decoupled of resource use. So we cannot really deliver climate neutrality objective without thinking about the economy. The economy is there to sustain our lives and to sustain our citizens, and but what we want to show with this European Green Deal is that it is possible actually to deliver all the products and services of our society without actually impacting on the climate and on the environment. Of course, this transformation is not going to be easy. I mean, it is really a transformation of the entire economy and society. And that's why there's a very big focus also on the social aspects, that no person and no place is left behind. And there's a lot of financing directed at lower income countries, but also lower income citizens across the EU. And the overall objective of the European Green Deal is that 1/3 of the available funding and financing that is made available goes for climate action. So that's just like really the high level of the European Green Deal. What I wanted also to show, to say at this slide, at this moment of time, is that the objective for 2050, which before when I spoke to you was still a proposal of the European Commission. Now it is not anymore a proposal, it is already enshrined into the EU laws. So it's a real objective. We also the objective to reduce emissions by 55 in 2030. So if you go to next slide, please. This increased objective for 2030 is the reason actually that we came with a new set of proposals, or revised set of proposals for 2030. Because in fact, all the proposals like the emission trading scheme, renewable energy directive, energy efficiency directive, with all the objectives for 2030, they were already decided. But with less ambition. And well, we listen to the scientists, we listen to the citizens, and this is why the Commission actually came up with a proposal to increase the ambition, to increase it to 55 overall reduction of emissions to 2030. So here on that slide, I'm just like, I picked a few of the proposals because in fact, there's so many proposals which actually address this objective, but just those which are really important for this audience, for the CCUS stakeholders. First and foremost is the EU emission trading system, which actually covers about 43% of the emissions in the economy, and it had an ambition to reduce emissions also by 43% in 2030. Now this ambition is increased to 61%. It is ambitious, and the ambition is ambitious, but it is feasible. This is what we also believe. In addition to that, there are other sectors that are included into the emission trading system. And on one hand, that is maritime transport. On the other hand, there is next to it, next to the emission trading system, a separate emission trading system will be put in place to cover road transport and buildings. With an own objective of 43% in 2030, it is just because it is actually more difficult to reduce emissions than in industry and the power sector. Why I'm mentioning road transport and buildings, perhaps not so important, but overall really important, that the carbon pricing mechanisms are expanding to other sectors, and overall the carbon price signal is going to increase because that has an impact on all innovative technologies, including on CCUS. At the same time, I mentioned that there is this social aspect of this transition that will make actually energy more expensive and services more expensive and products more expensive. Next to these proposed revisions of the directives, there is also a proposal for social climate fund with quite a big sum, 72 billion euro over like more or less 5-year period of time, because it can start only towards the middle of this decade. Then another element which I wanted to point out is the natural carbon removals, because we talk about CO2 storage, and about CO2 storage combined also with biomass and direct air capture, and that is very important. But at the same time, we're also looking at natural ways to remove carbon. And these natural ways, natural pathways actually found in land use, forestry and agriculture. And this is why there is a target which is going to, is increased to 310 million tons of carbon per year. So it is actually more or less on the same level of the target for technological pathways in terms of carbon capture, use and storage. But it is also, as I said, it is the emission reductions have to happen in all possible sectors and by all possible pathways, technological and natural. And finally, there will be more allowances. Well, finally, I mean, for that slide and for what I want to say, because the time is really short to cover really comprehensively the Fit for 55 proposals. But just to say that also the Innovation Fund, which is a key support mechanism for CCUS, will increase by volume to potential total of 49 billion euro, which, well, you always have to keep in mind that the amount of funds is dependent on the carbon price, so these are only estimates. So if you go to the next slide, this is a slide which I really like with these graphs, but I have showed this to you in previous times, and this is still the most important modeling we have on how to reach our climate objectives in 2050. And here I just want to remind you that these bars which are circled are the scenarios which bring us to climate neutrality. And these are the volumes of CO2 capture and CO2 stored and used that we have to have in order to reach the climate neutrality objectives. Now, what changes through the Fit for 55 modeling? Unfortunately, I don't have a graph. This still doesn't exist, a graph with a revised modeling. But I've been talking to colleagues, and they actually say that they can see in the modeling that there is like a higher amount of recycled carbon, so use, and direct air capture than in the scenarios before. But irrespective of the exact proportion of the type of CO2 that will be captured, or whether it will be the exact proportion between the storage and use, still the volumes are really important. And we are still quite aware that we need substantial volumes of CCUS, and many of those CO2 storage solutions have to be combined with production of bioenergy or with direct air capture, which can allow net carbon removals or negative emissions, because this is the only way to actually compensate for emissions that will come still from transport and agriculture in 2050. So if you go to next slide, this is again, I worked on the slides actually which I had before on the EU policy for CCUS. Again, here I just want to point to the new elements from this year. And one of the new elements is, as I mentioned, the revised EU ETS, which we expect to strengthen the carbon signal on one hand, but also we are removing some possible regulatory barriers to, for example, CO2 transport, which before under the EU ETS was possible only to be done by pipeline. Now it will be open to any transport by any means. Then there is another element that is added, that CCU options that result in the CO2 being permanently chemically bound in a product would also not need to, like such activities would not need to result in surrendering of allowances. So in a way, certain ways of using the carbon dioxide will be put on an equal footing with geological storage. However, we are fully aware that the volumes that CCU options can deliver are much smaller. This type of CCU options, not the fuel option, is still can provide big volumes, but it's unlikely that CCU fuel options would be covered by in the EU ETS. It's more the options where CO2 will be bound, for example, in building materials through mineralization. But still, the volumes that we expect to be relevant are those that will come from geological storage. And also in the Renewable Energy Directive, there is a concrete target. Actually, it should reach 2.6%. I've forgotten the percent in 2030, which would be the target for renewable fuels of non-biological origin, or so-called, well, CCU fuels. And then there are further legislative proposals of the Refuel EU Aviation Initiative, Fuel EU Maritime Initiative, that will ensure also sufficient demand for synthetic fuels based on CCU. So if you go to next slide, please. Yeah, so what else? Actually, one important element, maybe I will just note it very briefly, but I can talk about it much more in the next webinar or event organized by CO2 GeoNet, because it is something to do with a forthcoming communication on which is planned for 14th of December. And the communication is working name for the moment is called Restoring Sustainable Carbon Cycles. And it is actually the first step towards creation of an EU certification system based on the greenhouse gas performance of low carbon basic materials and for carbon removals. So these we will be calling them carbon removal certificates. And what's important is that through this system, technological pathways like CCU, but also more importantly here in this forum, DACs and BECs can be incentivized with this EU level scheme, because for the moment such carbon removals can be incentivized only through the voluntary markets, but that they are not, there is no EU incentive towards them. So this is really in very brief terms what I wanted to say about the Green Deal. Actually, Ceri, I don't know, I have just 4 slides which are on the Innovation Fund, but perhaps in the interest of time I can skip them because I'm not so sure how relevant these are for the audience.
That's entirely up to you. You have an extra sort of 5 minutes to talk, so it's okay. Up to you.
Okay, great. No, then I will present them because I will be short, but it's because we are running the Innovation Fund, as I hope most of you know about the Innovation Fund, because here with this presentation, actually, I'm not explaining the Innovation Fund. I'm just like a few slides to show you the first outcomes of the Innovation Fund calls for proposals. And actually on this slide, you can see an announcement that we did in July this year, because we finished the first round of 4 proposals for small scale projects. And also there were a number of projects selected for project development assistance from the large scale call. So if here it's a nice actually map, which shows that in fact proposals come from all the sectors of the Innovation Fund. And if you go to the next slide, I have a bit more specific slide on the 32 successful projects from the small scale call, where you can see that actually there are 2 projects which are in the area of CCUS, and the one of the projects is on the fabrication of CO2 negative aggregates. So this is this sort of aggregates will be capturing permanently CO2 in a novel process in aggregates. And then the second project that is selected is called Silverstone, and it's based in Iceland. That would be a full-scale CO2 capture and mineral storage at Shady Power Station. So it's only 2 projects out of 32. You may think perhaps not too many. That is true, but I must say that the small-scale projects, they have a capex limit of 7.5 million investments, so they are really quite small. So for the scale of CCS, indeed the small scale coal is perhaps not so relevant, although we do see, as you see, projects coming in. And if you move to the next slide, we actually likely to see more projects and more important projects in the from the large scale coal. We are still in the middle of the process, or maybe towards the end of the process. We have passed the middle, because we received already in the first stage an overwhelming number of proposals, 311. 292 of those proposals admissible and eligible. 117 proposals pass all minimum thresholds of the 3 criteria which were relevant for the first stage coal, meaning that they are all good enough. Out of them, we could invite only 70 to apply at second stage. And these 70 proposals, I must say, they had a total request for EU funding of 6.7 billion euro. And we have for this fund only 1 billion, meaning that there is like quite a big competition for the fund. So out of these 70, 66 proposals submitted full application, and they are under evaluation now. We will be announcing the winners in mid-November. So as I must say, if you move to the next slide, this is kind of an analysis of the proposals we have received, not so much based on sector, but based on technological pathways. And you can see here the share of CCUS is much bigger than the 4% we had in the successful projects in the large scale, in the small scale coal. So here we have about 30% of projects with at least one element of capture, utilization, storage, but quite often more elements, or full chain projects. So you will hear on that more from me at the next occasion. And just really one last slide to say that at the same time we are working, if you could move to the next slide. Yep, thank you. That we are already preparing the second call for large scale projects, because we plan to open the call on the 26th of October this year, with a deadline in March 2022. The volume will be increased to 1.5 billion. At the same time, there will be a second call for small-scale projects, which is planned for March 2022, so a little bit later, with the same volume of 100 million as the first small-scale call. So a lot of things are happening, and I hope I provided to give you some updates. I'm sure I've missed a lot of things, and I'm sure there's a lot more going on, but this is what I could think of saying, and I hope it has been useful.
Thank you very much, Maria. So I'd like to ask everybody to put questions into the chat, as to try and allow us to have as many people able to ask questions as possible. So I thought that was a really wonderful presentation covering all of our talks. So I particularly enjoyed the increased ambition and the fact that the Green Deal has affected all the areas of policy in the last 3 to 4 years. I thought that was a really useful sort of comparison. And I also really pleased to see that CCUS is getting involved. I'm very excited to hear that you're available for our next webinar.
Yes, with pleasure.
Thank you. So we look forward to this, and it's really good to see things moving forward and real projects coming forward. So I see we have a quick question coming up in the chat about utilization.
Mm-hmm.
So would you?
Yeah, I managed
answer?
to read it quickly when it appeared. So yes, CCU. In fact, the certification scheme which we are foreseeing for CCU as well will be based on project by project analysis. So it is quite likely that well, CCU fuels based on fossil CO2 are not going to deliver emission reduction. So we will see. It will be based on a life cycle assessment. On the other hand, there's as I was showing on one of my slides, there's already the Renewable Energy Directive, which actually has support for renewable fuels of non-biological origin. So there, in fact, it will be possible to use CO2 of any origin, so long as the renewable electricity you put in the process, so it is truly renewable. Sorry, so long as the electricity is additional renewable electricity. So yes, it will be possible because such fuels, in fact, do deliver greenhouse gas emissions. And then on top of that, something I didn't have on these slides is the recycled carbon fuels, which are actually also can be from fossil origin, but again, they will have to do a sort of an LCA, and there would be a minimal threshold put for the greenhouse gas emission reductions from those fuels, and all this will be specified in a delegated act by the European Commission, which is still not published. And this is DG Energy is involved in the development of those.
Thank you, Maria. And I don't see any other questions coming up yet. So maybe I will ask one. So you have talked about the innovation fund and larger projects. How do you see this expanding into the future? We've got such ambitious 2030 targets and 2050 targets. How do you see the European Commission expanding? Will it continue with the innovation fund, or do you see something else coming?
Thank you for the question. Actually, I only mentioned in passing on one of the slides that the proposal is actually to increase the volume of allowances, which will naturally increase the volume, the overall available money to, well, an estimate of 47 billion. So already the volume is huge. Then we are thinking also of developing a carbon contracts for difference. And I think this is something which would be key for helping the commercialization of these technologies, because as it is with the calls for proposals, we will fund the best projects, but there won't be enough to really help the technologies be widespread. So that's why a mechanism like the contracts for difference, this is where it can actually help the really many more investments to happen at the same time, rather than like each time there would be a call. Of course, we also rely very much on the work of the member states to support innovative technologies, and we see, especially in the area of CCUS, very positive moves by Norway, or of course, but also the Netherlands, which has their own contracts for difference scheme.
It is getting very complex with national and international funding all feeding together. I know this from just trying to follow the UK CCS process, being quite challenging to work out. So thank you, thank you for this information. Okay, so I think we're trying to ready to move on to the next speaker. Thank you very much,
Sure.
Maria.
You're welcome.
So we're having a few connection problems. So I see Rick from the University of Alberta. Are you on and ready to present?
You caught me off a little guard here. I was muted and hidden and all the rest of it. Yeah, sure. I can present something. Sure, if somebody's having some issues. Yeah.
Yes, please. We're having a few connection issues. So
okay, sure.
All right. To bump you to the top of the session.
Sure. Yeah. Let me boot in. Sure. Yeah. Let me just fire the presentation up here and then share the screen. Give me 2 seconds. I need Zoom, share.
You have a lovely background going on there.
Oh yeah, well, at the early morning of Edmonton. So that's our a view of downtown Edmonton, and just over my shoulder is one of our brand new bridges over the Fort Saskatchewan River. Yeah, so I thought I'd put up an Edmonton picture. So so is the screens okay?
Yeah, we
Ceri?
can see you.
Yeah.
Yep.
Okay. So it's 15 minutes. It's it's not a great deal of time, so we'll see how well we do. So let me get started. I think I know when Connie was kind enough to extend an invitation to speak, she asked if I would talk about new Canadian projects, and the Canadian landscape is changing very, very rapidly. So I'm probably going to do a particularly bad job of this, because it probably changes as of yesterday, and then will change as of today, because we have a brand new election happening in Canada today, and so we may get a new party in place, which might change all of the policies. So we'll see what happens. But so let me get started. There's a couple things, some CO2 stuff, just some overview comments. A few of the projects, Alberta Carbon Grid, Pathways to Net Zero, Polaris. I think you'll hear from Shell a little bit later today. And then one of the things that's really moving us pretty fast in Alberta in particular, and it may be adopted in other provinces, is something called sort of a competitive sequestration hub proposals. And then I would remiss if I didn't actually share one little tiny detail of some technical of interest from Aquastor, which is another project that's ongoing. So, one of the things I think in Canada, definitely most people probably on the call have heard about Boundary Dam, their capture project, and then CO2 being shipped off to the Weyburn field for CO2 EOR, which would be on the utilization side. But the project Aquastor, which is it's got an injection well and an observation well, injects CO2 quite deep into the basal Cambrian sandstones. From a project point of view, and I'm not really sure how things are evolving in the EU landscape, but what Aquastor has really shown up is that even if you're in the world of utilization, that buffer capacity for storage, especially if your corporate commitment is to not emit, and you're going to commit to billions of dollars in capture, and your goal is to not emit, that having buffer capacity is extremely important, but it brings about a very dynamic environment. So it's one of the things that's been an interesting lesson from Aquastor. But the other thing that's really, like in the EU, North America, worldwide, is this conversation around hydrogen. And definitely there's lots of moves afoot in Alberta to move hydrogen in multiple pathways. Most people have roadmaps, but to the transportation sector. But what that has brought is a huge conversation around CCUS, especially geological storage. And so I'll explain how that's happening. So definitely Bob Dylan is particularly right that the times they are changing. Most of you on the call will be very familiar with these four. Again, there's a talk about Shell coming up later. Weyburn, Midale, huge, been going on for quite a long time. Boundary Dam, Shell, there's an update presentation later. And then, of course, one of the sort of first in the world full-on operating networks, hub and cluster kind of approach for taking CO2 from Fort Saskatchewan industrial heartland pipeline to a CO2 EOR field and injection and subsurface. So they, doing well. I think they're up to maybe two megatons of injection now. So, but I'm going to touch on a couple others that have shown up in terms of projects in Canada that I think bear a little bit more similarity to things like Portos, Aramis in the Netherlands, Northern Lights, and so on. So, there's been lots of announcements. Pembina Pipelines, essentially, and TC Energy announced this thing called the Alberta Carbon Grid. Huge for the province. If it goes ahead, these are a lot of announcements, but they're on paper and out in public. So they have a northern leg, central leg, southwest leg. Some of these are substantial. 15 in terms of a transportation corridor, right? Really, it's an enabling transportation corridor. The north, 15 megatons per year. This is particularly interesting when you see the next project that's coming up, this Pathways to Net Zero. Central 7 megatons per year, Southwest 7 megatons per year. But what's intriguing is that has to be married with storage. And again, I'm highlighting a thing that's coming up a little bit, is that this competitive process that's just begun to look for pore space. And you can see how the blue dots in the area of Alberta, you start accepting 15 megatons per year. You're 3 times the nameplate capacity of Gorgon. These would be massive projects. So the part that's intriguing is that this gets stacked on top of another initiative that's focused on oil sands, and there has really been an aggressive move in the last 5, 6, 7 years beyond the normal moves towards energy efficiency, fuel switching, and so on. But this Pathways to Net Zero announcement by the 5 major, we call them the 5 major oil sands producers, and this is a big effort, a trunk line again, a pipeline. Maybe it might be the Alberta grid, I don't know, but collecting all of the CO2 from the oil sands area and moving it to a joint sequestration hub down here near Cold Lake, and this is a large project, substantial. So this is another place that's going to be competing for pore space. In combination, that there are studies as well to look at how to utilize CO2 in geological storage in Lloydminster area as well from the Saskatchewan side. Perhaps the Shell presentation will be coming up, but everybody's familiar with Quest for sure. And so this is Edmonton here, and you've Quest up here to the northeast, and it's sort of rated 27 megatons of storage for the current version of the project. But just recently, the announcement of Shell proposing Polaris. And Polaris is going to occur, Josephburg, this little blue dot location here is Fort Saskatchewan. This is where all the hydrogen manufacturing units are. And this purported size is 300 megatons. It's an order of magnitude larger than Quest. And you combine that with a whole bunch of other things that are happening. You can see that we have industrial decarbonization is happening. There's other power, fuel switching to natural gas that wants to put stuff. So now all of a sudden in this area, you're starting to look at 4 and 5 and 6 megatons per year. And so these projects start to get stacked on top. But what is happening is we have this. There was so much desire for pore space that the Alberta Department of Energy had to back up, hold off, sort of froze pore space, and then now is in the process of requesting expressions of interest. There are these hub environments. I think most people are familiar with those, but now what's happening is you are going to be granted a carbon sequestration agreement that has certain conditions that go with it if you're successful. So when you're given this grant, then you will be given the right to drill some wells, conduct some evaluation, injectivity, capacity estimates, and so on. And then one of the agreements is that if you are given a hub, you have to have a commercial structure that allows CO2 to arrive at that hub. You have to accept CO2 from multiple locations. So this starts to be kind of an interesting set of conditions. So it'll be interesting to see how this rolls out. It's a very competitive. This will drive everything. It is driving now all of those other projects you saw there. And will be interesting to see how it works out as people sort of struggle with sort of looking after their own commercial terms and how this evolves in time and basically in time enough to sort of support the growth. I think at the core of it, I think most of us are aware that there are ISO standards and other things that people can look to, and so now for the most part, I would suggest that in Western Canada now, well beyond sort of, let's call them science projects. These are going to be people going after hubs that are going to have to make very significant and difficult commercial decisions about what does the MMV look like. If you look at even a recent presentation from Shell and Quest, our colleague Simon O'Brien, many of you know, the thing that he's talked about there is how far backwards they've come from essentially the first level of MMV programs instituted at Quest, which were done on purpose, were very aggressive to ensure that sort of the maximum amount of safety and security was demonstrated from that. But they've learned over time that there are a lot of those that can come off, if you like, and don't have to occur, for instance, up until closure. So there's going to be lots of those decisions that are going to be exciting to see happen in that commercial space. So maybe just at the end, just a couple notes about the Aquastore and the sort of dynamic operating conditions, just to put a technical flavor on this. One of the things we have learned, a couple things, is some really interesting questions around the geology. I put this up mostly because we did a comparison between the deep geothermal project, which is 25 kilometers to the west of Aquastore, you can see here. But what's interesting is the reason I put this up here, and we did this, is that Deep, along with other people, are also exploring how to actually marry geothermal and geological storage of CO2 in combination, not necessarily working fluids, but in combination and stuff. So there are lots of moves, both in Alberta and in Saskatchewan, people thinking about those options. So again, this is proven to be kind of interesting about how just regular log information can be converted pretty quickly. That matches what's happening in Aquastore. But just a final little bit I wanted to say about the dynamic data. And I think many of you working on larger projects now will all know this, is that over time in these dynamic environments, as you inject and you shut in and you inject and shut in, especially if you're serving as a buffer capacity, you get multitudes of pressure buildups and fall-offs, shut-ins and fall-offs, which are extremely valuable to look at over time. And that's really something that has to be built into your programs. It's shown amazing value in Aquastore. The other thing about Aquastore and the dynamics is related to the cooling and the heating. And I think most people, we've seen lots of literature, salt precipitation, other things, and temperature conditions, and people worrying about PVT and equations of states and stuff. But what's interesting and again, would be remiss if I didn't say geomechanics, so I'll just say geomechanics, is that if you do the simulation, just if you look at this plot in the upper right-hand corner, if you look at Aquastore data, and you look at how it behaves, if you look at these blue crosses up here, this is pore pressure changes leading to changes in effective stress in the rock, which is the total stress minus the pore pressure. If you only do a isothermal analysis, then your stresses stay up in this positive region. But if you include non-isothermal, so you include the fact that the temperatures are cooling, people are starting to look at, you look at Portos and Eramus and projects like that into depleted gas reservoirs are very sensitive to this issue. You can see what happens is that over time, as you cool, you can bring the states of stress down into something that's very tensile, very negative. And what we've found, and that's really the next slide, and then I'm done, is if you look at this and you interpret only field data, you look at this right-hand plot, why this is important is that if you look at this x-axis, which is the effective stress, so this is the positive side, this is when we start, and then as I inject over time, I cool the reservoir, and as I cool, the effective stresses drop like I did in the last plot. But these represent changes over time, and you can see what happens 2015, 2016, and if you look up here, 2019. But what you notice is that when you get into this minus 5,000, there's kind of an inflection point here that happens, and you get an increase in the permeability index, injectivity index. And what's interesting is this matches very, very closely to the sort of tensile strength of the deadwood on average. So this is really kind of intriguing because we think that what's happening here is that, yes, we have really high saline fluid. Yes, salt precipitation is kind of interesting. There's some other videos perhaps people have seen me present on. But what's interesting is that this other mechanism is actually overcoming any of those blockages and are still leading to sort of orders of magnitude increase in injectivity index. So really, some really important results. The other last thing I would do with people on the call who are thinking about instrumentation and stuff, don't forget something as simple as a bubble tube. We had some failure in gauges in the observation well that was 150 meters away. We decided to convert a permanent fluid recovery system to a bubble tube. It's a pretty simple little tube that just bubbles nitrogen gas into the well. And so if you look at this little snapshot of data, The orange that you see flashing on the screen is the injection well data. This is the CO2 downhole, bottom hole pressure from the injection, and the purple line is the bubble tube off 150 meters away. And it really has done an outstanding job. Simple, robust, not fancy. Like it's just it is a really effective method to gather information in the subsurface. So even something as simple as a bubble tube. So pretty fast. I think in Canada, especially in Western Canada, this request for expressions of interest, this competition for pore space is going to be an intriguing evolution. I think you have to keep your eyes on that. And like I said with Bob Dylan, for sure, the times they are a-changing. So thank you very much. A very short summary, and if anybody does have any questions, I'd be happy to answer.
Thank you very much, Rick, and thank you for jumping in a little bit early while we were sorting out the connection problems.
No, that's okay.
So I very much enjoyed your perspective, as well as the interesting points that you raised on buffer capacity and dealing with CO2 from multiple sources, because that's something that, as you say, as the times change and the CCS starts to move around more freely and from more sources and into more storage sites, then it does become an important issue to think about where the CO2 is, who owns it, and how it's being managed. And I like your description of sort of bubble tubes as simple. I'm pretty sure that you're underselling the expertise that goes into getting these samples and processing them properly. And
I do see a question in the thing about Gillian. Yeah, the answer is no, not very much. I would have loved to have been wider Canadian perspective, but there are maybe like the very first talk, there are the smaller volumes, if you like, of CO2 utilization in conversion, mineralization and things like that, but they're at the smaller volumes. Really what's capturing a lot of the attention and even some of the targets from some of the funding avenues are these sort of larger volumes of CO2. So yeah, I didn't really cover 50 minutes, pretty tough, but there's not most of the substantial attention, even on the industrial decarbonization side, lie in Western Canada. There are cement, carbon cure, cements, a few things like that, but they're just not the large volumes.
Thank you very much, Rick. And if anybody's got any other questions, please do drop them into the chat. We'll have a bit more of a Q&A at the end of the session of talks. So Stephane from Equinor, I believe you've conquered the firewall issues. So please, the floor is yours.
Hello, can you hear me?
Yeah, we can hear you.
Yeah. Okay. Hi. Sorry, I had a few issues on the firewall, but I eventually managed. I can share my screen. Hopefully, it should work. And I can put that in slideshow. Tell me if you see my screen.
Yep, we see your screen now. Thank you.
Okay. So I'm going to introduce myself. I'm Stephane Vignau. I'm the subsurface manager of the Northern Light project. I guess you had already a few presentations on previous seminar about Northern Light. So I will just give the status of the Northern Light project, but more on a subsurface point of view. Briefly, okay, so a generality. This is a really quick overview of the project, as my presentation will be focused on the subsurface. We are in Norway. We plan to inject 1.5 million tons a year of CO2 as a phase one. The idea is to get the CO2 from a plant who capture their own CO2, transport it through boat, and send it 2.5 kilometers below the seabed through pipe after a temporary stop in the plant. Okay, so the main message of this presentation is to show the contingency that we had for the subsurface job. It was necessary to do pre-investment for facilities, and mainly the onshore storage and the satellite, without much data, and that was one of the challenge. The storage complex in a semi-regional aquifer, a saline aquifer, sloping towards the north in the lower Jurassic Dunling group. I will go into more detail on that, and it's within the exploration license 001. What we did during this project in subsurface, it's we try to span a range of geological concepts and uncertainties to try to see what was the best way to develop that. And we try to get a pretty agile attitude with a swift evaluation process by testing many assumptions pre-well and after the well result. The FMU, which is fast modeling software from Equinor, in-house proprietary, was very flexible and flexible enough to be able to incorporate all the well results and to deal with static and dynamic uncertainty in a big loop, I would say. So what is a storage? So that it's an evaluation that we did pre-drill. We drilled the well since, and I will try to run the story. So as I said, the storage complex, and I don't know if you see my. Can you see my mouse? Not sure. See if you can. Well, I hope you'll see my mouse. So the storage complex, it's a Dunling group at in the lower Jurassic. It's Johansen and Cook formation, and that geological storage. The Drake, which is in gray here, it's a primary seal, and it's a seismic reflector, and it ensures the containment of the injected CO2. And we've got secondary, I would say, secondary seal from the surface with the Rogaland, the Shetland, if you go down, that Cromenol and Rapney group as well on the overburden. We see that this is a well, this is expected CO2 that's based on simulation. We don't inject yet on the well, and that was pre-well. When I was speaking about sloping aquifer, it's 1 to 2 degrees. We had no penetration, only a few meters of core from a well which was 20 kilometers north of the license. And what we knew, it was a high energy shallow marine environment with a north-south changing coastline with a deepening toward the west to go towards the sea. We expected sand. We didn't really know how much we would have, what was the quality of this sand, and how much they were extended. So we tried to assess the main parameter for the injectivity was very important for us. So it's a classical parameter, net to cross porosity, the presence or not of a barrier, baffles, connectivity of sand, vertical permeability, relative permeability, etc., affecting the CO2 plume migration in terms of distance and in terms of speed. As you see that the plan is for the CO2 to move towards the north within the troll field, but the challenge is not to pass a boundary license before the end of the troll field. So when I was speaking about subsurface methodology, what it do, the plan was to make in place a methodology that allows us to cover the span of uncertainty before the well, and being able to react pretty fast after we drill the well. For that, we look at seismic interpretation. We did some large-scale correlation. We identified 5 potential depositional concepts with attribute map, vertical, lateral trend, and we had, as I said, with the FMU, we had a very flexible approach by injecting a lot of different parameters into a model with a big constraint, the license boundary towards the north. So it was static and dynamic uncertainties, and when we were able to drill the well, we could update the model very, very fast with that. The criteria to proceed for the FID, because we had to propose the FID even before the well was drilled, it was the sound presence, but the quality as well, and the monitorability, the connectivity and the injectivity of this reservoir, and the pressure in the Dunlin, as of course the pressure will have an impact on the density of CO2 and therefore an impact on the storage. So prior to the well, two main actions on top of the one I just showed you there has been done. It's a containment risk analysis, of course, that was to identify possible migration paths, to assess the barriers, and to put in place some mitigation measures to deal with the consequences. The point was to make sure that it was safe, and so we had the full integrity of the storage of the CO2. We end up with a negligible risk for the CO2 to reach the seafloor, or impacting the troll field, which is produced from the Viking, which is above primary seal. We had this containment risk analysis, but we plan as well, of course, to do monitoring plan. So monitoring plan was this four different area. The land facility, of course, so we'll be quick on that to just stay on the subsurface. The inspection of the pipe, all the classical. Some injection monitoring, injection rate, pressure and temperature through gauges into the well, and the main monitoring system was 4D seismic and 4D seismic acquisition in order to follow the CO2 plume, but as well a recording of the passive seismic. So when we did that, we drilled a well. The well was very good. It showed very good result with high petrophysical parameter in our reservoir. We took almost 130 meters, of course. We managed to reduce the number of depositional scenario from 5 down to 2. So with that, we could increase the confidence on the connectivity we could foresee into a system which is deemed to be deltaic and surface. Reservoir, 4 reservoir, Johansen 1 to 4, Johansen 3, Cook 1 and 2, and Cook 3. And you could see that in any of the reservoirs, the porosity is pretty high, up to 23%, with very good net to gross apart from the Cook 3, but the net to gross is around 90% and minimum 70%. Well test very good, 72 decimeter wasn't expected. We did the radius of investigation has been from 2 to 3 kilometers, so we could define connected volume between 2 and 3 kilometers without any border barriers. We saw that in the Dunlin and Dunlin, Cook and Johansen, the pressure was initial, it was hydrostatic, it wasn't depleted. And we did an extended Dickoff test on the seal who give us some confidence for the caprock integrity. So when we did that, this is some resume of the well, post-drill data, 106 meters of net sound, very good quality, very good injectivity, good mobility, high net to gross. We could correlate the sound, no depletion recorded, good seal, and we were able to assess the reservoir after the swell. As I said, thanks to that, from the 5 sedimentological concepts, which is also 5 potential uncertainties, we went down to 2. So it was much better for us. And with that, we updated the model to redo some assessment of uncertainties, and especially the CO2 migration with the distance on the view of the northern boundary. So as a summary and conclusion, so it's just what I said initially, pre-investment, it was a large constraint. We had to define the storage complex, and we had to get a very flexible approach. I think that we succeeded in that. However, the well has been a great success. He showed us what we wish it for. He screened out most of the proposed concept. It allows us to reassess the geological uncertainties, understanding, sorry, and to update the geological model. And it confirmed the storage capacity for the phase 1, which is 37.5 million of CO2, which is 1.5 million a year for 25 years. Of course, some work remains to be done. We want to prepare the 3D seismic acquisition we done in 2022 to be used as a base for the 4D monitoring program. And regularly, we will do some monitors to assess the CO2 migration. We're going to drill 2 wells in 2022, in September 2022. One is a sidetrack of the existing well, so the uncertainty is pretty low in terms of properties that we're going to encounter, but we're going to drill a well as well on the south of EOS to be able to de-risk this area. A new model will be built in light with this new well result. Hopefully, the well number 2 will help us to improve the understanding of the south of the area because we don't have any well over there. It will enable us to estimate additional storage capacities that we try to simulate in the model and support some future well location decision and update the CO2 migration simulation. And that's it, what I'm saying. It was a bit long, I'm sorry. Thank you. Got any question?
Thank you very much, Stephane. There are a couple of questions that have already appeared in the chat, and I have to say I really enjoyed this preparing for swift decisions aspect from your talk.
Well, we didn't have much choice. We had to, because it was a lot of money involved with the FID to be taken, formal investment decision to be taken prior to the well. Generally, we tend to do FID after a well, so that it was a bit challenging.
I congratulate you. This looks like a really, really good presentation, really interesting and very efficient data processing. So there are a couple of questions in the chat for you as well that you won't have been able to see when you're in presentation mode. But we have a quick question for Northern Lights. Any updates on optimizing costs of the monitoring plan? Too soon?
We've got some an initial plan just now for the monitoring, but it's very soon. What we decided to do is to go for without the PA pressure and temperature gauge downhole. We're gonna go for 4D for 3D repeated seismic, a 4D acquisition, and we decided to go towards monitors after a given volume, not a time. So hopefully, based on this volume, we'll be able to optimize after the cost, but it's very early because we haven't prepared yet the base seismic.
Thank you. We also have another question. I've noticed the occurrence of several faults affecting the reservoir formation. Several of them potentially represent gas escapes, as you've highlighted. Are some of them potential barriers to CO2 flow? Did you already perform analyses concerning this aspect?
Yeah, it's part of the containment risk analysis. I've been very fast on the containment risk analysis because I should make a full presentation of it. We tend to cover all the aspects from faults, from cap rock integrity, from fracture as well due to thermal effect of the CO2, but as well through legacy well, etc. So all the fault has been evaluated, and the containment risk analysis has been done on that. Yes, of course.
Thank you. And we had another question. How far away from the injection well will the CO2 plume migrate? And how much time will it take?
I would like to answer this question because it's still main uncertainties. As I mentioned, the main risk is for the CO2 to migrate out of the license boundary into troll license before the end of troll production in 2054. So what we did all our simulation to make sure that we will not have any CO2 crossing the boundary. So with a given simulation, I would say that the CO2 should move around few hundreds of meters a year towards the north. But until we haven't started the simulation, we see only 2 to 3 kilometers around the well. It's difficult to answer this question just now.
It's very much a process of evolution between the monitoring and the modelling. So
Sorry?
I see it very much as an evolution between the monitoring and the modelling. So for Sleipner, for example, we saw huge improvements in the modelling even after a short period of injection, with real data to prove which aspects of the models were accurate.
Yeah, exactly. When we'll see the plume, the CO2 plume migration, we will be able to represent it as much as we can by changing the petrovesicle, the connectivity, the baffle eventually, until we will be much more predictive. Just now, it's very early stage, especially when we haven't done any injection yet. Injection start in 2024.
Yes, and this is excellent news for CCS in Europe as well, to have this network project, because for me it's very interesting to see the projects. We used to call them demonstration projects, then they become flagship projects, then they become kind of like anchor projects that start off the whole CCS network that we really want to see evolve. So thank you very much for this.
You're welcome. It's the first industrial project. Yes, it's hopefully we will prove that CCS is working. I'm sure we will anyway.
I'm confident that you will.
Thank you very much.
Thank you very much to both of our speakers. We did have another question in the chat about the optimal method for CO2 capture for enhanced oil recovery. I don't know if there is anybody who wishes to speak to that from the industrial side of things.
Can you say the question again? Sorry, I missed it. Where was it?
It was very early on in the chat. 144. It says on my screen. So I have a question about the optimal method for CO2 capture for enhanced oil recovery.
So there is. Well, I can say from Western Canada, I know the one process that is garnering a great deal of interest and application is a solid sorbent technology by a company called Svante, SVANTE, and it's a very fast, scalable kind of technology, and there sure is a lot of people applying it. It's been applied now in multiple smaller locations, so it seems to be working extremely well in the EOR world. Yeah. That's as much as I know about it. I'm not a capture expert, but I do know that the Svante system seems to be getting a lot of take up at the moment.
That's really helpful. Thank you very much, Rick. Okay, we had another question on which software do you use for simulation or modeling for any of the presenters?
So I suppose it's fair for me. I can answer that in the presentation. It's a FMU, fast modeling update, which is a proprietary tool from Equinor in-house, and that allows us to deal with all uncertainty, static and dynamic, in one go. So it's very powerful, and we end up with a range of few hundred realization, and we've got a spam of uncertainties. We don't have a base case. We've got 400 cases that deal with all the uncertainties. That was for Northern Light.
And generally for the stuff that's happening here, I think most people are going to sort of non-proprietary internal software. So they will go to CMG. A lot of people will use CMG gem codes. In our particular application and work on these projects, we couple those current codes to a sort of family of other sort of codes. If in like Stephane's case, if there are optimization routines, we'll typically deploy CMOST from the CMG families. And then, and then as he noted, from the reservoir simulation point of view, there's multiple people that will use the CO2 options in Eclipse.
Yeah, so it's true that it's a FMU, and there is a question makes the use of Eclipse, in particular for thermal effect. Eclipse intersect as got this CO2 capability yet. However, we have to remember that the phase 1 was a service agreement with Equinor. They use a in-house software. For the phase 2 and beyond, hopefully, the joint venture will probably use a commercial software, as we won't have access to a proprietary tool from Equinor.
Thank you very much. And we had another question. What is the optimum CO2 storage technique for gas and improved condensate recovery? If anybody wanted to tackle that one.
Yeah, not the geomechanics guy. It's hopefully somebody else.
Okay, maybe we'll park that one and see if we can have a think about it, or if anybody comes up with anything later. I mean, for me, for improved gas recovery, I'm only aware of using CO2 or other fluids as a cushion gas, and that it's a slower process than enhanced oil recovery. So I've read that it took sort of 10 years or so to receive the full benefit from using a cushion gas for enhanced gas recovery. But we are a little bit outside of my area of expertise, so I wouldn't like to comment further. So apologies, I don't think we can tackle that one much further. Okay, I'm going to suggest that we take a short 5-minute comfort break. And we have some more speakers lined up to you. I'd like to thank our speakers from the first session very much. Thank you very much to Maria, Stephane, and Rick. Much appreciate your contributions. And just to let everybody know that the recordings and the presentations should be available after the session. But obviously, we'll come back to the speakers and ask specifically for your permission to post your slides, etc., to make sure if there's any last-minute changes or anything that you want to adjust before this goes online. So thank you very much. Oh,
thank you very much. I won't be able to stay, unfortunately, but thanks a lot. And if there is any question, well, the session is finished now, but if there is any question, please don't hesitate to send me an email and I will answer that. But I've got other commitment, unfortunately. It's a bit hectic just now.
It certainly is. Thank you very much for joining us.
Thank you. Bye-bye.
All right, thank you. So everybody, so it's just about 15 minutes past, so we will come back at 20 past 3 for those of you in Europe. Have to do my time conversions. So thank you very much, everybody. We'll see you in 5 minutes. Welcome back to the second session on emerging CCUS technologies and new projects. So we've got some exciting new projects introducing some of the innovative aspects for CCUS and future directions. So Niels Schwarzbo from GEOS, I see that you've managed to connect, so please can I invite you to share your presentation?
Yes, thank you. Can you hear me all?
Yep, we can hear you.
That's good. Yeah, I had some technical problems. Sorry about that. So let me see if I can, how it works in Zoom.
At the minute, we can see your profile picture, which has some very interesting abstract art from this distance.
Yeah, I am. I'm just sharing the screen now. I guess I will take my video down. Good. So you can see now my screen?
Yep, we can see your slides.
Good, thank you. Yeah, I'm going to talk about the project Greensand, which is an emerging offshore CCS site in the Danish part of the North Sea. And I'm speaking not just on behalf of myself, but especially on my GEOS team of researchers who's listed here, Dan and the other ones. And then I would like to say that this is a study that is funded by the Danish Energy Technology and Development Demonstration Program. And it was to a consortium consisting of INEOS, Wintershall Dea, and Maersk Drilling, and GEOS. So I'm talking on a very larger project base. So what I would like to show to you today is just to show how Capture CCUS is fitting into the Danish climate strategy. And I'm going to talk a little bit about a new roadmap for CCUS in Denmark. And then I'm going to talk about Project Greensand, how GEOS went out testing the reservoir and seal. And then I'm going to conclude on the Greensand project. So the CCUS in Danish climate strategy is very important cornerstone for the government to achieve its 70% reduction in greenhouse gas emissions by 2030, and also to have a net zero emission by 2050. Here you see all the CCUS value chain with the source and the capture and the transport and the different utilization options, which is currently discussed in Denmark. We have just made, headed by GEUS and the Technical University, a new roadmap to deliver how CCUS can be delivered to Denmark for meeting these goals. And then the Danish state has earmarked about 50 million euros in research and development projects and pilot projects right now within the next 1 year. So we are very busy in Denmark doing projects and bringing CCUS solutions to the front. What the roadmap shows here is that the technical sides that I'm going to talk about in the reservoir is not just the only thing that is missing for the implementation of CCUS solutions. That is very much also a regulatory framework and a lot of other issues, but I'm not going to dwell upon those things today. The Danish storage possibilities are huge in the Danish subsurface, and this map from GEOS shows that we have more than 22 million tons of potential storage of CO2, and both in on and offshore and in saline aquifers in depleted oil and gas fields. So the Danish subsurface is not just relevant for Denmark, but also as a possibility of a storage hub for Northern European emissions. And the arrow points to the Nini field, which is the Project Greensand location, and it's an offshore field in the Danish part of the North Sea. The Project Greensand is set in the Nini field, and this just shows you a little bit about the geology or the geography. It's located in the Ceri Canyon, shown on the map to the left. And on the map to the right, it's shown that it's a Paleogene sandstone, the Frick member, and it's a glauconitic, what we call a green sand also in that term. And it's lying within the Horda formation in the Paleogene sands or clays. The Project Greensand in itself, there's a homepage where you can go in and see the progress of the project. But it consists of a project consortium. It's INEOS, Wintershall Dea, and Maersk Drilling as the commercial side of it, and then GEOS represent a research partner. And it has a lot of phases to end up by delivering a potential site in the Nini field. And we are currently working on, or just completed phase 1, which is the screening and appraisal phase. The next phases, we have plans for reaching those, meaning that the Nini site potentially could already by 2025, in 2 years or 2 to 3 years time, could have the first Danish pilot place for CCS storage if the funding needed is acquired. The Greensand phase 1, which was supported by the Danish national funds, had a lot of work packages, and I'm going to report on 2 of these work packages: the reservoir compatibility with CO2 and the sea rock capacity, which was the most research-related project parts. At GEOS, we have a REC for testing reservoir compatibility with CO2, and we can conduct supercritical CO2 brine cyclic injection at reservoir conditions, and we can conduct critical velocity tests, and we can also monitor the chemical reactions between the reservoir and CO2 from prolonged brine experiments, which we did in the terms of the Nini sand. And here we have the reservoir rig at GEOS, shown to the right. We tested the reservoir injectivity, shown here with the diagram to the right. both for the brines and also from supercritical CO2. And we did that from extended pore volumes of injected brine and CO2, and in altogether 4 different experiments. And we found very reproducible permeabilities, and these are shown here with normalized to the gas permeability. We did not see any permeability reduction as the different CO2 brine cycles were delivered in the lab. And we did not see any physical changes in the permeability or reduction in permeability with increased flow rate, which is shown out of the x-axis, which was 2 of the most critical parts for evaluating the reservoir as a potential CCS site. We also investigated the stability of the reservoir when we exposed it to CO2 flooding, and we only noticed very few mineralogical changes. As I said, it was a glauconitic sandstone, which is essentially a clay mineral, but we found that the clays and the mineral frames were stable. What we saw was that the carbonate phases, mostly the siderite present in the rock, experienced dissolution when exposed to CO2 saturated brines, shown here with the pictures to the right compared to the pictures to the left, which is prior to experiments. And then we saw a little evidence of ion exchange reactions, which we're currently investigating because they're very minor, but just to show that the main stability of the rock framework was intact. We also investigated the caprock integrity and capacity. This diagram to the right shows the Nini 4th exploration field, which is in the Nini West field, and it's divided into the Nini West Seal complex. And you can see that it has more than 800 meters of thick Paleocene clays on top of the reservoir, which is shown in green down here. We both had extensive core testing and cutting testing, and also tested the chemical reaction between CO2 brine and seal. And then additionally, we looked at mud gas analysis of the seal. This is just to show you just a few slides. This is to the right, you see the very fine thin sections, very fine grained, with the only major components are composed of filled diagenetic Ölandit minerals and filled in with from diatomites present in some of the sections. We also did particle size distributions, and we found that very, very little of the caprock consists of sand, and these sand-sized particles were mostly diagenetic filled in particles, and most of that, not to say everything, is composed of silt and clays. And consequently, all other properties, such as the surface area and the mercury injection capillary pressure entry data, showed that it is a very, very tight formation, also proven by the fact that it is a proven seal in the area. And this just shows you some of the logs that we have from the Nini area, showing the mud gas composition in at top of the Nini area. And we can use these mud gases, which is gas measured in the mud composition during drilling, to ascertain if there are any gas that is currently migrating up through from the reservoir. And as you can see here, both all of the area, the wells in the area, and those on top of the Nini West field, the Nini 4 well, they do not show any gas accumulations top of the reservoir, indicating again that we have actually an intact seal on top of the site, which is again proves that it is a working seal complex. So just to conclude on the Nini field, that CCUS is a very important piece of technology for implementing the Danish or to have Denmark to reach its emission targets, and that's already by 2025, which is very, very quickly on. We are advancing very quickly the green sand project, and we aim to mature this as an offshore CO2 storage site in the Nini depleted oil field already by 2025. This means that given the appropriate funding possibilities, that we can in fact be launching the first CO2 storage site in Denmark based on this project here. We have made extensive laboratory testing of the reservoir and the seal, and we looked at well log data and all points that the reservoir is compatible with the supercritical CO2 and that we have a very high seal rock capacity. We have the following the ISO standards and for describing the DNV standards for describing and characterizing the reservoir and seal rock, and we have also in subsequent projects. And again, I would like to stress out that the Danish underground offers plenty of opportunities, both on and offshore, for storage of CO2, and that we have potential in Denmark to offer a storage hub for European emissions, not just for Danish emissions that we have here. So I think this was all for me as a quick update to you and to the GeoNet community on the project Green Sand from Denmark. Thank you very much.
Thank you very much, Niels. And it's really great to see CCUS playing a key role in such ambitious targets. And for CO2 GeoNet, it's really exciting to see how countries are planning to reach their proposed emission targets, and to see that CCS has an important role to play. And it's also interesting, I note that you said you'd follow the ISO standards, which is also very useful information to understand how sites are preparing for this. So we have a very quick question, I think. Is the Nini field an oil or gas field?
The Nini field is an oil field. It has a small gas cap, but it is an oil field.
Thank you. And I think we'll just hang on to the other questions for the discussion session, if that's all right. But I think there's a lot of them coming up in the chat, so thank you very much for those, everybody. I'd like to move on to Kristin Jordal from SINTEF, talking about the capture of biogenic CO2 and transport and storage in the North Sea. So Niels, can I ask you to close your screen down? Hi, Kristin.
Hi. Okay, I can't share screen yet. There. Okay, I'm that far. Let's see if I can manage to share my screen. This. Can you see my screen now?
Yes, we can. Thank you.
Perfect. Thank you. So I will present you the ACCSESS project and talk about capture biogenic CO2 for transport and storage in the North Sea. I'm thinking maybe it's under the North Sea. I'm a capture person, so I may be wrong. Apologies. A little bit about general about the project first. ACCSESS, the long name, providing access to cost-efficient, replicable, safe, and flexible CCUS. It's a Horizon 2020 innovation action that just started now in May this year, goes on for 4 years. We're coordinating from SINTEF, and we have a total budget of 18.4 million euros with an EU funding of 15 million euros. And it's really our projects, it's split into 3 parts, with the blue part, which is really the main part, with the capture demonstration and analysis of capture, and also CO2 use, recarbonation of the demolition concrete. I won't talk more about that part, more about the capture later. But then we also analyze the chains, the green part here. We want to develop and improve CCUS chains from continental Europe and the Baltic area to North Sea. Then we have a societal part, want to engage informed stakeholders and explain societal benefits. And we have a, research hypothesis that working towards cities that strive for sustainability can create a driver for CCUS. We hope that at least. And then we have a vision in our project to develop replicable CCUS pathways towards a climate neutral Europe in 2050, so that we should develop something that we can deliver and say, look, this is how we could do it one way or several ways of doing it. And we all know that's a theme here. We all heard Maria Velkova also that there is a need for net removal of CO2 to reach the 1.5 degree target, like the sixth assessment report of the IPCC Working Group 1 talked about that anthropogenic CO2 removal or carbon dioxide removal leading to global net negative emissions would lower the atmospheric CO2 concentration and reverse surface ocean acidification. So the industrial sectors in access can contribute to net carbon dioxide removal from the atmosphere. And the extent, of course, depends on the sector that's addressed. And I'll show you on the next slide which are the sectors we are addressing. We call ourselves a climate positive project. I think it's maybe a typical SINTEF way of talking, or a carbon negative project. So we're working with 4 industrial sectors in this project, which is pulp and paper, essentially purely biogenic emissions. So we can have with 90% CO2 capture up to 90% carbon dioxide removal or removal of biogenic CO2. Now, waste to energy, it's about 50% carbon dioxide removal, depends on the actual composition of the waste, but roughly 50% biogenic. Then for cement, the situation is different, since we know that 2/3 of the emissions come from the calcination of limestone itself, then 1/3 from the fuel. So depending on the fuel, we can have approximately 30% carbon dioxide removal or net negative emissions if you use biofuels. And then we also know that cement or concrete constructions absorb further CO2 during their lifetime. Then the 4th sector we're working with is biorefineries, and there it depends on if you retrofit an existing refinery, maybe you can remove half or a little bit less than half of the emissions. A novel biorefinery would only have biogenic CO2 emissions, or could have that, and then you would have the same carbon dioxide removal rate as for pulp and paper, for instance. So we're going to pilot CO2 capture in this project. And we have 3 elements that we put together here. It's the existing Fortum Oslo Varme mobile pilot plant that was constructed for their large-scale CO2 capture project that they are now allowing the ACCSESS project to use. We're going to run this pilot plant with the CO2 solutions by Cyclone solvent, which is an enzymatic potassium carbonate solvent. So it's not an amine, it's an environmentally friendly solvent that uses an enzyme to quickly absorb and desorb CO2. And it regenerates at the temperature below 100 degrees, which is quite interesting, actually. And then we're also going to combine this with a rotary packed bed absorber that could make the absorption column much more compact and not so high. So these 3 elements will be commissioned together at the Technology Center Mångsta before we take this mobile rig first to Sweden to test at a pulp and paper mill in Skutskär in Sweden, Stora Enso, and then go to Heidelberg Cement in Poland, Gorazde, where we will test it for another 6 months at this kiln. And then the aim, in accordance with the conditions in the call, is that we would have reached Jordal 7 for the Cyclone and ProSpin system, which is system prototype demonstration in operational environment. So capture is the main part of this project, but we also have a chain analysis. This is getting back to the map that is on the first page, where we have taken what we call a holistic approach on the CO2 chain analysis. This is a very busy map. But you can see that there are 4 pink dots here, which are what we call our pioneering chains that we will analyze to begin with, and analyze the techno-economics with the current technologies, both for capture and transport, and then storage offshore Norway. And then analyze the legal and regulatory framework, do an LCA assessment for the environmental aspects of CO2 transport, CO2 chains from capture to storage. Then we will further on the project both look at improved technologies for capture and transport, and also migrate the analysis to other areas, other emission points among our partners. We see examples of them in green, and then we see which ones we select in the end. And we will, in the end, deliver an open source code for optimizing CCUS networks over time and in space. And then for the final third part of the project, it's this about the connecting sustainable cities development and CCUS, where we are in the consortium, we used expertise to help Fraunhofer, who are the partners working on this, on the citizen engagement process and analyzing concerns and needs, and also informing and targeting information materials that to understand what is not possible to understand, and generate information and material for this, and also target neutral information packages explaining more to cities how do you replicate or how do you use technologies or replicate CCUS-based solutions in a sustainable city context. If it's waste to energy with CO2 capture, building constructions or built with concrete, with the cement using CO2 capture, carbonated demolition concrete, printing paper, buying printing paper that's produced with CO2 capture, running the traffic fleet on biofuel with CO2 capture, whatever that could be, and then in the end come up with a handbook on how CCUS-based solutions can be implemented as a part of sustainable cities development. Then summary, a lot of text, apologize for that, but some of the targeted results to give you some numbers is that we're going to demonstrate 2 tons per day the CO2 solution by side capture with ProSpin rotor packed bed absorber. We're going to demonstrate at an even larger scale, 5 tons per day, this combination process for demolition concrete recycling, so we have a permanent fixation of CO2 in a CCU process. We're going to investigate how to integrate CO2 capture in these 4 industrial segments with a targeting and a CO2 avoidance cost reduction of 20 to 30%. That's our target. Then we have this replicable CCUS chain development methodology that we'll deliver with the open source code. And we're also addressing tank-based CO2 transport solutions and aiming for a 50% cost reduction, with the main thing then, of course, is to reduce the pressure, transport pressure from around 15 bar to around 7 to 8 bars. And we will deliver a handbook on how CCUS can contribute to sustainable cities development. We only started a few months ago, so we don't have any results to show to you yet, of course. This is our consortium, 18 partners plus 4 linked third parties. And with that, we also have to acknowledge the funding of the European Union. We have a very simple website up and going. It's coming, another better one is coming soon. You can also contact us on email and on Twitter. So thank you very much for your attention.
Thank you very much, Kristin. And I wanted to say, as a storage person, I particularly enjoyed your slide on the life cycle kind of analysis for the capture. So we had pulp and paper, sort of, there was much higher capture percentage than for some of the other, from cement, etc. So for me, that was really useful. Something for me to understand as a storage person. So thank you for this.
Thank you.
I did have one quick question on the CO2 avoidance. You wanted to cut the costs by 50%.
No, 20 to 30% on the avoidance,
okay.
Then 50% on the transport.
Okay, all right, this was my misunderstanding. I was just interested to know the difference in sort of avoidance rather than capture.
The avoidance is over for the capture integration, because you need to take additional energy use into account when you start capturing CO2. So you can't just look at the cost of capture. You have to look at the cost of the CO2 you actually avoid to emit. That's why you use the avoidance cost.
Excellent. Okay, thank you very much. Thanks. So thank you very much, Kristin, and we'll move on to the next presentation. So Sofia, I see you online. Excellent.
Hi, good afternoon. I can share my presentation maybe. Is that okay?
Yes, please, if you're willing to do that. Otherwise, I saw you'd sent us the slides as a backup as well.
Yep.
We can see your screen.
You can see my screen. So, okay, good afternoon, everyone. I'm going to talk on a slightly different topic. So I was asked to come here and talk about hydrogen. And I guess you're now all wondering why is she talking about hydrogen and what that has to do with CCUS, or maybe not, but that's what I would like to discuss a little bit with you. So some context, as in many other parts of Europe and in the world, hydrogen has become super popular in the last 2 years. And what you can see in this slide is a lot of media articles on hydrogen in Portugal, and it has gaining a lot of attention in lots of different economic and also political fora. So there is a huge discussion on hydrogen, the role of hydrogen, and what do we want to do with hydrogen in our economy. So it's a really hot topic, and recently we had published a national hydrogen strategy that sets some targets on green hydrogen for 2030. And I say green hydrogen because we are clearly, we are not interested as a country in having blue hydrogen. So it's only green hydrogen we're talking about. And we have very ambitious targets on green hydrogen production for the next 9 years. So we have 9 years to make the hydrogen economy appear in Portugal. And to let you know, at the moment, we don't really have any massive hydrogen production. So this is going to be a big challenge. And one interesting thing maybe is that one of the goals of the strategy or the vision on green hydrogen is that by 2030, about 2/3 of this green hydrogen is going to be exported. So the concept is to use solar electricity, cheap solar power, to produce hydrogen with green electrolysis and to export it to other countries in Europe. So that's the mindset. So what does that have to do with CCUS? Well, actually a little bit, because although what I'm showing you now is a report on some supporting studies for the Portuguese green hydrogen strategy, there was a lot of energy modeling work underneath the strategy, and it's clearly stated in these documents that blue hydrogen, as I said before, is out of the question. So we are not interested in having hydrogen produced from natural gas reforming and using CCS. So that's clearly a political no-go in Portugal, but it is envisaged that we want to combine the hydrogen that we're going to produce, the solar hydrogen we're going to produce, we want to combine it with captured carbon dioxide to produce renewable fuels of non-biological origin, as methane, methanol, and jets. So that's here, this is the lynch point where we can bring together CCUS and a hydrogen economy. And it is envisaged in this publication that we'll have a very, actually quite large capacity of these production processes with substantial CO2 capture as well. There is, this is not a project my institution is involved, maybe some of you heard about it. There are ongoing projects in Portugal focusing on mapping sites for CCUS. There are some, what you're seeing there is a map of Portugal, of coastal Portugal, and there are some large producers of CO2 that are nicely located near to some areas where you could store it underground. And some of the things we've been dialoguing with the researchers involved in these projects is what would be the interest and viability of, going a bit deeper in assessing synergies between green hydrogen production and CCUS with a view to this production of synthetic fuels. And some of the things we've been discussing, because at the moment everything is open, is would it be more interesting to have hydrogen production located next to large CO2 sources, or would we instead wanted to capture CO2 and transport it to where you have the large hydrogen production facilities. And I have to tell you, at the moment, everything is possible. So everything is still undergoing. So here at LNEG, we do a lot of work on the hydrogen world, but I would like to just talk to you about this one, where we are trying actually to map these synergies between hydrogen production and other factors affecting hydrogen competitiveness. So we are developing a Portuguese atlas for sustainable green hydrogen. And what we are doing here is actually mapping. It's very clearly making a map where we try to combine the different factors that determine the suitability of a certain location for locating a hydrogen production plant. And of course, one of the factors is the proximity to a large CO2 producer with at least an interest on the technical possibility for CO2 capture. So we are looking at things on which are the determinants that affect the environmental permitting and the environmental suitability of a certain area, which are the criteria that will determine that certain locations cannot be considered from a land management point of view. For example, if we're talking about nature protected areas, and on a different note, what are the possibilities regarding available infrastructures for storing, transporting, and distribution of hydrogen, because that is a big issue on the hydrogen world. So we are looking into things as distance to consumers / CO2 producers, places where we can inject hydrogen in the gas grid, other types of transport possibilities, and underground storage possibilities for the hydrogen. And of course, we also look into water and power possibilities to feed green hydrogen production processes. So in other words, this is how it looks like. Basically, each little square you see there is a GIS layer, and we have different layers for the terrain, from slope to territorial planning. We have different layers for resources to input our electrolysis processes, because we are only considering green hydrogen as being produced for water electrolysis. So we need to look in different water sources and different green power sources. And then on the right hand side, we are getting closer to CCUS there, because we are looking at what we call the market conditions to sell the hydrogen. Once you have your hydrogen, who could be the potential consumers, and how can you deliver the hydrogen to your consumers? That makes a big difference in the costs. So we're looking into things like the location of end-use consumers, things like injecting the hydrogen in the natural gas grid, again, underground hydrogen storage, and of course the location of major CO2 producers in Portugal. So the idea on this mapping exercise we are doing is that we have all these different layers that correspond to different criteria to determine the suitability of a certain place in mainland Portugal, and we overlap them all to find what we call the best locations for hydrogen production. And again, location CCUS possibilities are one of the factors. So what this allows us, with using different weights of these different layers, to have different scenarios of locations. So we could have one scenario where we say, okay, we are thinking that the possibility of having CO2 capture is very important, and we give it a higher priority than other possibilities of selling our hydrogen. So it's quite flexible. So in a different way, this is how it looks like. It's a mathematical index that we are developing with the GIS. It has a water input component, a power input component, and a market component, where you can see there large CO2 producers with CO2 capture possibility. Basically, we combine all these different layers, and then we run over them all the results, this big black white box in the middle, where we exclude all areas that we think are land restricted, either because they are in a very slope, with very high slope, or because they are nature protected, or because they are very important for agriculture. So these types of things. And we end up with a map in Portugal where we can locate green hydrogen projects. And this is an example of a map you see there on the right-hand side, but it already shows, it exemplifies what we are working with. And I think you will see one of the pink areas there is really located to the same place where the strategy CCUS project is looking for the CCUS. So it's naturally one of the potentially interesting places. Yeah, so this is here is just to show you there are different maps of Portugal with different colors that to show you how the different layers look like. So it's not very complex. Basically, we are mapping the mainland Portugal territory in different with different classifications according to solar power resources or wind power resources or water sources. And the weird chart on the right hand side, the map with lots of green dots, is where you have the potential consumers, and some of them are of course large CO2 emitters. And this is, I'm getting towards the end. So this is our map at the moment where we identify that we have large CO2 emitters in Portugal, and where we think these companies, and there you see cement, glass refineries, and also some large natural gas power plants. So the idea here is that at least some of these will be interested and committed to have CCS, actually some of the cement plants, and maybe some of them will also be interesting to explore CCUS and take the hydrogen to produce synthetic fuels. So these are some of the things we're looking at. And so just to wrap up, yeah, this is some ongoing work we are doing. This green hydrogen atlas is going to be made public by November of this year. Yeah, the hydrogen economy is it has a lot of facets, a lot of different ways to look into it, and one of them is synergies with CCUS. So CCUS is not so fashionable in Portugal, if I might say so, but I think maybe hydrogen is a way to bring it, you know, on the table again, and to think maybe this is interesting. So yeah, thanks a lot from my side, and I'm very open to take any questions you want to put on the table. Thanks.
Thank you very much, Sofia. It's really, really interesting to see how fast the work is going on hydrogen in Portugal. So thank you very much for this, and I look forward to seeing a hydrogen atlas later this year. So that's really interesting. We had one question in the chat. Do you think political acceptance may change when taxonomy, i.e. the carbon footprint, is used rather than colours for hydrogen?
Sorry, can you maybe? Yeah, actually I do. Yes, I really do. I have to say, I don't think that's maybe the biggest, most important thing, if it is a taxonomy or the but yeah, I really think we need some clarity here, and we need some clear guidance. And I think hydrogen is a fascinating example. Until 2 years ago, we didn't, in Portugal, no one wanted to talk about hydrogen. It was old-fashioned, and it was boring, and it was explosive, so no one really cared about it. And then suddenly, just because of a change, not in semantics, but also in political attitude, it became extremely interesting and appealing to everyone. So yeah, I actually think it will help to have this carbon footprint more clearly established. And also, I really think it could help us to also make full use of CCUS in a country that doesn't like it so much. Thanks.
Thank you. I agree, and I agree completely on the idea of looking at the full life cycle carbon emissions from all of the different technologies to make sure that we're comparing things fairly, and that we understand what implications there are for our activities. Going back through the questions, I saw there were quite a few for Niels as well, for the Green Sun project. So I see, is the public acceptance in Denmark for onshore storage?
I think that we have not any onshore storage in Denmark for CO2, but obviously it's the public acceptance is just by analog expected to be higher offshore than onshore, but there is not any specific public assessment studies made to gauge the status of the perception.
And another question for you as well. Would it be legally possible to import CO2 into Denmark for storage? So obviously the London Protocol has been revised, but what do you think about that country specific?
It's not legally possible as of now, and it's not legally possible either to store CO2 as of now. So there's a lot of legal changes and ratification of different protocols that has to be in place. But it's definitely something that the politicians is seeing as a opening, and could be a important part for the CCS implementation, that we can be allowed to import other European emissions. So we expect that the legal regime could change, but we have definitely laid that out in our kind of roadmap, that there are major legal obstacles for implementation of a hub solution for Denmark.
I think I saw from one of your colleagues that it was being debated in Parliament in July for changes for CCS legislation.
Yeah, it's ongoing. I mean, the Danish political regime is very fluid at the moment, and is moving very quickly. So there's debates going on before summer, and also in the autumn when the Parliament is reuniting again.
Thank you. And I just wanted to say, if you have any other questions, please do post them in the chat. And we also had another more specific question for you, Niels, asking about if there was an active aquifer in the area where the Green Sands project was being modelled, and how was the active aquifer modelled?
There is an active aquifer in the area, and the specific modeling and how it was made is made from other in the consortium, and I cannot answer that question.
Okay, thank you very much, Niels. I very much enjoyed the afternoon session, and I don't see any other questions popping up in the chat. So maybe I will ask a difficult one. So we keep saying CCS in 5 years' time. When I started back in 2000 working on CCS, we were saying, oh, CCS will be big in 5 years' time. So I wondered if any of the afternoon presenters would like to talk about this. How fast do you think CCS is developing? Are we going fast enough, or do we need to go even faster to make sure that we develop safe and efficient storage?
Well, I can perhaps start saying that in Denmark, I think we are moving at a maximum speed at the moment. And that is, as I mentioned, that the current drawbacks is on the legislation part, that there are so many uncertainties with respect to the legal aspect, and also transferring of rights from a production permit to a storage permit. How is that going to be? So I think that actually the most obstacles right now is not on a technical, but that is in legal issues right now. And for technical parts, we can be quite quick, but we don't know the exact legal environment that we are going to operate in, and that is a big uncertainty that is likely to draw down speed considerably.
From the UK perspective, somebody asked me about this, if I was sure CCS was going to develop. And I said, for me, it was more a question. I knew where it was going to develop, because the same storage sites keep coming up every time we look at this. It was just when was harder to gauge. But I'm very optimistic in the UK now that we're really driving hard towards CCS, that it's going to develop faster in the way that we first expected it to when I first started working on this way back when. I see there's another question in the chat for Sofia.
Yeah, thank you. I just saw it as well, and thanks for the question. So you're asking if in the upcoming years, permanent CO2 storage will occur in Portugal, also on a larger scale. And what I'm going to say is completely my own personal opinion. And of course, there's a lot of things I do not know. And to be very blunt, I wouldn't put Portugal as one of these countries where in the next 5 years this is going to appear. There's a lot of other countries much more active with much more experience in interest than Portugal. So if you define the upcoming years in the 5 years, no, I don't think we will have permanent CO2 storage. But of course, again, there's a lot of things I do not know. If we think about 2030, then maybe, yes, maybe we will have some CO2 storage. But again, I'm just guessing. Thanks.
Thank you, Sofia.
Ceri, if I may add to your question on this horizon, and it's indeed the horizon, like it's the line that is all time moving forward together with us. Now, I think indeed that the chances that now we're talking about the 5 years is significantly higher than they used to be 15 years ago. Again, if you look in Norway, and in addition to that, to the storage license that is the Northern Lights project, we now have a second round for the purely CCS licenses, and they're going to be allocating 2 different areas. And I can also see that in Norway there is now a whole span of the different concepts coming in, and then people talking about the ship transport. There are different companies who set the CCS really as their one-off or the key focus on the operation. So it's really, it seems to me now, transferring from lower to higher and higher TRL, and we're talking more and more about value chains. We're talking about the actually projects that are happening or going to happen really soon, and the projects that are led or have a lot of industry participating in it, comparing to what it used to be. So I think 5 years is not the horizon any longer. It's the goal.
Thanks, Roman. I'm pleased to hear the optimism.
Maybe I can just complete from the capture perspective. I mean, CO2 capture technology is commercially available today, so that's not a showstopper. At least the cost for implementing it and knowing how you should do it on your particular industry, well, the cost is more of a hindering than know how to implement it. I mean, you can find that out. So I think that's good news. We can do it.
I 100% agree with you.
But I was also thinking back, if I can make it, about when you talked about starting in the early in this century. In about 2008-9, there was a lot of talking about that in 2020 we will have like 8 to 10 to 12 capture demos in Europe, and that never happened. But I'm much more optimistic this time, actually, that we will see it happen.
Thank you, Kristin. Yes, I agree with you that we've said this for a while for CCS, that the barrier is more cost than it is technical. We know how to store CO2, we know how to capture CO2, we know how to transport CO2. It's very much down to the cost and when it starts and how much more it costs to not do anything than it costs to do something. Unfortunately, that's much harder to gauge than it is how much it's going to cost you to build a capture plant tomorrow. But we have to keep pressing forward, and I'm very optimistic now about the developing future for CCS. So we are coming towards the end of the webinar. We didn't manage to track down one of the speakers, unfortunately, but we still had a very interesting presentation, really good session today. I would like to ask if people are happy to turn on their cameras so I can take a picture for our annual report so we can show how many people attended the webinar, and then I'm going to hand over to Roman for the closing comments. So I'm going to do a screenshot.
It's basically as good as it gets right now, right, with the screenshot.
Afraid so. So we'll do some screenshots. There's two screens of you, so I'm going to take a couple of screenshots. So thank you very much, everybody, for attending. And I'm going to take a photo in 1, 2, 3, go. And I'm going to do the second screen as well. So ready? 1, 2, 3, go. So thank you very much, everybody. Roman, I'm going to hand over to you for the final comments.
Well, to be honest with you, Ceri, in addition to what we have just discussed, I don't have that much to add. I think it was a very exciting session. I'm very happy to see so many people participating. Looking at the chat, I think that we're getting really good at exchanging information and networking in chat, which is a bit of a scary thought, actually. But I'm really hoping that by, I'm always optimistic. You can hear it from my comments. But now I'm also fairly hoping to be fairly realistic and expecting to see everybody next year in person for interactions and networking. At least me personally miss a lot from our several open forums, but this is as good as it gets. Lots of questions, lots of good interactions. Thank you a lot to all the speakers for sharing and everybody for having this as a very lively and an interactive event. That's really, really important. And again, maybe just to summarize the things that we have discussed with Ceri just now is that it's very exciting to actually see that in majority of the talks, we're talking more and more about the value chains, about the high TRL projects, and we have more and more industry participation and involvement. So we really see the CCS, well, changing in politics and removing some of the barriers is extremely important aspect as well. So it's very exciting to see this change from the CCUS or CCS being more kind of an R&D area to having it more and more industrial process. It doesn't mean that we would need less research on it. There is a lot of the industrial process that still require a lot of the R&D efforts in terms of making them more efficient or better. But it's really, really exciting to see this higher TRL. And with that having said, I don't want to distract you from having a wonderful evening. And we really hope to see all of you. And then hopefully, if you enjoyed it today, many of your other colleagues who couldn't make it or knew about it, also tomorrow. So thank you very much for joining and see you again very, very soon.
Thank you very much, Roman. Thank you very much to our speakers. Take care. See you tomorrow, I hope.
Thank you. Bye.
Bye.
And bring